Hey scholars, I hope you're doing well today. For this lesson we're going to look at three theorems for similarity. One is going to involve parallel lines cut by transversal, and the other two will involve triangles. So make sure you're paying close attention and taking good notes. Let's get going. Alright, so for our first theorem we're going to talk about the triangle proportionality theorem. It states that if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. Okay, so let's make sense of that. The line parallel to a side of a triangle, so here's a line parallel to the side, so this side BC, line EF is parallel to side BC, and it intersects the other two sides. So we can see it, that line intersecting at point E and point F. So it's parallel and it intersects the other two sides, so it divides those sides proportionally. So these two sides are going to be divided proportionally. So AB is divided into two parts, AE and EB. AC is divided into two parts, AF and AC. So then we see how we can set up a proportion here. AE over EB equals AF over FC. Okay, so basically what we're seeing here, a way we can set up this proportion is to say AE over EB. So since they're on the same side, they compose the same side, you put AE in the numerator and EB in the denominator. AF is going to be on the numerator just like AE is, and then FC is going to be in the denominator just like EB is. Okay? And AF and FC are on the same side. So anyway, let's move forward and apply this theorem by working a problem. Okay, so we want to find CY. We're trying to find the length of CY. We could say that the length of CY is X. Okay, but let's set up our proportion first. We could say CY, and CY is on the same side as YA, right? So I'm going to put YA in the denominator. It's going to be equal to, well, we see across from CY, that short part of the side, right? Just as CY is the short part of this side. BX is the short part of the other side. So BX over XA, the longer part of that side. So it's going to be across from YA. So XA, and remember, CY and YA, they compose the same side of that triangle. BX and XA, they compose the same side of this triangle. Okay? So now let's just substitute in. We said that the length of CY equals X, so I'm going to say X over YA, which is 10, equals BX is 4, and XA is 9. So at this point we're just going to cross multiply and solve our proportion. So X times 9 is going to give us 9X, and then 10 times 4 is going to give us 40. We'll isolate X by dividing by 9, and then we get X equals 40 over 9. And you can leave that answer just like that, 40 over 9, that is fine. You can convert it into a mixed number if you want. That would be 4 and 4/9. Or if you convert it to a fraction, X would equal 4.4 repeating. You could put that in your calculator and you'll see that the 4 is going to repeat. All those are fine ways of representing that answer, what X equals. You know, we can just box any of those answers. All of them are fine. So that's an example of the triangle proportionality theorem. Let's move forward. So our next theorem is the two transversal proportionality theorem. It says if three or more parallel lines intersect two transversals, then they divide the transversals proportionally. And this is similar to the theorem we just looked at. We can keep these those transversals going, and you see that they make a triangle, right? So you could even look at this theorem kind of like you did the triangle proportionality theorem. But let's just make a little more sense of this. So we see that AC, so here's point A, here's point C, AC over CE. So AC and CE, they make the same transversal. They're part of the same transversal. So AC over CE equals BD over DF. BD and DF, they compose part of the same transversal. So let's go ahead and apply this on a problem. All right, so we're going to find A. Now, we don't have the names of the points of intersection here, but we can just go ahead and set this up. We can say A over 20, since they're on the same transversal, A over 20 is going to be equal to, well, what's across from A? 9. So I'm putting 9 right across from A. They're going to be both in the numerator. And then across from 20 is 15. Now you don't have to do this step, but something that I notice is that 9 over 15 can be simplified. So I'm going to rewrite this, A over 20 equals, I'm going to simplify 9 over 15. Well, 9 and 15, they can both be divided by 3. So 9 divided by 3 is 3, 15 divided by 3 is 5, and I'll just cross multiply here. 5 times A is 5A, which equals 3 times 20, it's 60. Divide both by 5, you get A equals 12. And I'll box that answer. Now, if you didn't simplify 9 over 15, you would still get the same answer. I just think that simplifying, if you can, makes it a little easier. You get 15 times A, if you cross multiply just right here, 15 times A is 15A, equals 20 times 9. You get 15A equals 180. You divide 180 by 15, you would still get 12. So I just think that simplifying it, if you can, makes it easier, but you'll still get the same answer either way. Now let's move forward to our last theorem. Our last theorem is the triangle angle bisector theorem. It says if a ray bisects an angle of a triangle, then it divides the opposite side of the triangle into two segments that are proportional to the other two sides. Okay, so let's make sense of that. So we've got a ray bisecting an angle of a triangle. Actually, in this case, this is not a ray. I can keep it going. It just looks like a segment, but we can keep it going. We can make it a ray if we want. All right. The point is, it's bisecting one of the angles of that triangle. So then it's going to divide the opposite side. So here's the opposite side. So we see it's broken up into parts X and part Y. It divides the opposite side of the triangle into two segments that are proportional to the other two sides. So we got A over B right here equals X over Y. So you can see that the two parts that have been divided, they're in the same ratio. We have X over Y here. Well, we see that A is going to match up with X here, and B matches up with Y here. Okay, so the sides have been divided. You can put them in the same fraction, and then make sure you line up the corresponding parts. You can see that X and A are on the same triangle, that smaller triangle here, and then B and Y are on the same triangle here. So B and Y are in the same. So B and Y are both in the denominator, A and X are both in the numerator. So just make sure you're lining up your corresponding parts correctly when you set up your proportion. So now let's work a problem with this. Okay, so I'm going to solve for X. So I see that we've got that angle bisector here, so it's going to divide these triangles proportionally. So I'm going to put 3.5 here. There's multiple ways you could set this up, so this is just one way. But I'm going to say 3.5 over X, since they're both on the same line here. I think that's the easiest way to start off. 3.5 over X, they're both on the same side right there. So 3.5 is going to match up with 5 since they're on the same triangle. And X is going to match up with 12 since they're on the same triangle here. So we'll put 12 right there. All right. So now let's cross multiply. 12 times 3.5 is 42. So we get 42 equals, then X times 5 is 5X. Now I'm just going to solve this. Divide by 5 on both sides. We get X equals 8.4. So then we can just box that answer, and there we go. So I hope that lesson was helpful for you. I know I only worked one example for each theorem, So it might be helpful if you feel like a little confused or anything to maybe look back over one or two or all of those problems so you can further get it down. Come to class prepared with questions and ready to work. I'll see you then. Good work today. Thank you, Collegiate Scholars.